Hi, everyone. I hope that you all had a lovely Victoria Day long weekend. So, this is why your video is coming out on Tuesday because we did not have school yesterday. I'm going to get into your new assignment, and you've got some time to wrap your heads around this and get it done. It's not due to be submitted until Friday, May 29th. So, this is reflective of our work we've done with simple machines and reflective of the content that we covered about the International Space Station and aligning with that theme. So this here is kind of a culmination of the last 2 weeks of Google Meets, where we were learning about the different types of simple machines, but also focusing specifically on it in terms of space. So this particular one here will kind of wrap up the content linked specifically to space. So this one here is looking at robotic arms. So if you remember when I talked about in your slideshow the Canadarm2 and the impact of that on the International Space Station and the contribution that we had towards that, this is catering to that content that we were discussing. So you are going to create an arm to try to grasp an object. Now that culminates a lot of what we've been learning about in terms of design, about like what shapes you might choose in order to do that, to like be creative in terms of the resources that you have and what resources might be the most effective to troubleshoot and problem solve when it comes to the resources that you have and the design that you originally might have intended on and changing that once you find that maybe it isn't actually the most effective design. So there's a lot that you can learn from this, it's purposely open-ended so that you can kind of choose to make this as intricate or as basic as you deem fit, depending on the resources that you have and the time you have and things like that. So you've got almost 2 weeks to get this done. And the video instruction link here is what I'm creating right now. So hopefully you found that. And I just wanted to highlight briefly some new vocabulary for this. So we have the rover, which is a space exploration vehicle designed to move across the surface of a planet or other celestial body. So this does kind of focus on like the Mars rover and things like that too. So I just put that word in there. Also a payload. So when we were talking about loads in class in terms of like the forces, then this would be the load carried by the vehicle. There's the cargo platform, which is the location on a rover designed to carry the payload. And then the real main thing is the end effector, which is the gripping device that's located at the end of a robotic arm and has an effect such as grasping on objects within reach. So the real things we care about this week is this end effector, so the thing that actually grabs. And so think of like, I don't know if you ever played those games in like an arcade or whatever. There's like a claw or like one of the, or those lobster claws that you can grab. Anyway, so like any claw grasping motion is the end effector. And then the load itself, right, that we talked about in class. So this here is just meant for you to have a creative design and hopefully have some fun while you're building this thing. So NASA uses these robotic arms, like we discussed, especially on the International Space Station, to actually capture approaching cargo ships and to do dangerous tasks that might be too dangerous for astronauts. Sometimes it's used to assist astronauts on spacewalks. So there's all sorts of uses for this big long arm that comes out of the International Space Station. And there's a specific link here that you can watch, which talks in more detail about it. And specifically, this one focuses on the Mars lander, but it does a pretty good job of explaining the importance of what we're doing now. So this here is meant for fun, and it's meant to get you creative and meant to have you kind of innovate a bit with the resources that you have. So you're going to build a robotic arm. So I don't want you to like freak out and think I'm making you build a robot. You're certainly welcome to, but it's not an expectation that you do that in 2 weeks. So it does not need to be actually robotic, but you're going to use your knowledge of simple machines and structures to come up with a design that you hope will perform certain tasks. So by that, I mean that it can grasp an object and ideally move that object. Okay. So your goal is to use any available objects that you have permission to use to build this model robotic arm, which is capable of grabbing an object and putting it into a container. So what do I mean by that? Now you can actually have an extension of your arm with a grasper at the end, which is much more challenging. And I encourage you to do that, especially if you're in grade 8. But if you are like, that is way too overwhelming, then it could actually just be as simple as you not grabbing something with your hand. Either way, you are still being creative, being innovative with the resources you have, thinking of a design and executing that design and then modifying it if needed. So this can be as simple or as complicated as necessary. So what I have for you, your goal is to grab an object and put it in a container. Now, that can mean a couple things. So that object can be anything. You have to figure that out first. It's going to be much more challenging to grab a heavy object. It's going to be much more simple to grab a light object. So you choose what is appropriate for you. And then that container, you can also choose what is appropriate. It can be something quite large. Maybe you have a Rubbermaid container. That's going to be much more simple to put the object in. Or maybe it's going to be much smaller. Maybe you have a bowl and you have to try and put it in the bowl. That's going to be much more challenging. So you can choose how much of a challenge you want for this. All right. And then for an added challenge, you can actually have tape at a distance at your table or wherever. So maybe I'm assuming a table is probably the easiest for this, but maybe table can mean a lot of things. It could be ping pong table. It could be whatever. So you're going to have a flat surface where you're going to put a distance apart. And then you have your container and with objects of various sizes to be grabbed. And then you can actually have the added challenge of doing that from behind a certain line and then placing the container further away and then trying to grab it. So this is much more challenging and is completely optional. But it is an added challenge to grab the object and put it in container without passing this 30 centimeter line and to try and grab things from further away. So that's if you have a long arm with the extension from your own hand. So this is completely optional. You can keep it very basic, but you can also challenge yourself to do this much more complicated version of it. So you're going to take a look at the materials that you have in your house, sketch out a design of what you think might work with this task. You're going to construct your arm and reflect on what went well and how you could maybe improve it. And very important is make sure you clean this up afterwards. So I don't want you leaving a mess for your parents. They got enough to deal with. You're old enough. You should all be able to clean up after yourselves. Okay. So in terms of the questions, I guess first things first, just to give you a brief example of what this could look like. So this is like the most basic version, but you can essentially just extend your fingers. So I'm using reusable straws. You could take these to your fingers and you could grasp an object that way, and you could reflect on why this is challenging or what went well or how you could possibly modify this design. That's like the most basic version, but you can have this much more complicated where you actually have a whole extension of your arm. You have maybe ropes or something that is allowing you to move the fingers, and then you have to figure out maybe something sticky or something at the end to actually grasp the object. There's all sorts of, the world is your oyster, as they say. That's the expression. Maybe you guys don't know it, but you know, you have so many possibilities. So look at what you have available to you, plan it out with what's reasonable with the time and what you can actually do, and then plan accordingly. Okay. So the questions for submission is for Friday, May 29th. So I have, what is the Canadarm 2? That's the first question. And so that's for grade 7s and 8s. Grade 7s and 8s, which simple machines did you use to create your robotic arm? And maybe, you know, if it's like something like this, where you're just extending your fingers, that would be like the lever, right? But try to think, even if it's not like perfect, think of what you think you used, you know? And so think critically about what you actually created and what simple machines might be in there. So that's for grade sevens and eights. Then grade sevens and eights as well. How easy was it to use and how effective was it? So how did it work? So that's for grade sevens and eights. Grade eights, you have 2 additional questions in addition to what the grade sevens have. So grade sevens, you stop there. So you submit those 3 and you build your I'm calling it a robotic arm, but really it's an extension arm similar to the Canadarm. And then grade eights only, you also are doing, are there improvements that can be made? If so, what can be improved? And also grade eights, you're going to do a bit of research on the different Canadian robotic arms, because there's 3, and then just look at some of the differences between the Canadarm, the Canadarm 2, and the Canadarm 3. So depending on what grade level you are, you have 3 questions if you're in grade 7, and you have 5 questions if you're in grade 8. So the whole goal of this is to get creative, to think of the design, to modify the design if necessary, and to ultimately have the goal of completing the task of putting your object into the target area. So I hope that I see some creative arms out of this. I love getting those pictures. I love getting those videos. So once again, if you can submit a video of this, that just, it puts a smile on my face whenever I see awesome science happening. So I certainly welcome that. Also, I love seeing photos. So you could attach a photo to this document at the end, which is another way to share what you accomplished. Or you can simply fill this out if that is not reasonable in the time you have or the resources you have at home. So this is something that can take you a lot of time, or it can take you less time, depending on kind of where you're at and the time that you have that you can contribute to this. So I look forward to seeing what you guys come up with, and be creative. And I hope I see some great innovation and examples of robotic arms in science. So that's it for this week. Thanks, everyone. Bye.